Good morning, my dear students. In the last class, we were discussing about the electric field on the axis of an electric dipole, and hence we derived the expression for the electric field on the axis of the dipole. In today's class, we will derive an expression for the electric field at a point on the equatorial line of an electric dipole. The derivation for this equatorial line is also very important. It is asked in the examination for the 5 marks so many times. So, to start derive the expression for the electric field, first of all, we must know what do you mean by this equatorial line. What do you mean by this equatorial line? So, equatorial line, it is the line perpendicular to the dipole axis. The line perpendicular to the dipole axis. The line perpendicular to the dipole axis. Dipole axis. So how it is? Say here, there is one dipole. There is one dipole. It is plus q and it is minus q. Let O be the center of the dipole. So this is the line which is perpendicular to the dipole axis. We know this is the axis of the dipole. This is the axis of the dipole, and the line which is perpendicular to the dipole axis, the line which is perpendicular to the dipole axis, we will call it as the equatorial line. So this is the equatorial line, and at any point on this equatorial line, we will find the electric field, and that is what the today's class, we are going to find the electric field at a point on the equatorial line. Alright, so equatorial line of an electric dipole. So I can find the electric field at this point, or I can find the electric field at this point. So this is the point P where we are going to find the electric field. So before going to derive the expression for the electric field, we will understand the figure, then only we can derive the expression for the electric field. Right? So let us say that electric field at point P we are going to find here. So let R be the distance of P from O. Let P be a point at a distance R from the O. At this point P we are going to find the electric field. So the electric field due to the positive charge is always away from the charge. We know this. So the electric field due to the positive charge is going away from the positive charge. Say here like this. So this is the electric field due to the positive charge. That is E plus. Alright. Then what is the electric field due to the negative charge? It is towards the charge. So electric field due to the negative charge is towards the charge. So it is nothing but what now? E minus Q. E minus Q. Right? So we have what? E plus Q and E minus Q. So let this P be the direction of the dipole moment. Direction of the dipole moment, and this is nothing but the distance A. This is distance A. Right? So E plus Q is the direction of the electric field due to the positive charge at point P. E minus Q is the direction of the electric field due to the negative charge at point P. So there are two fields now. If there are two fields, then definitely we will find the resultant field. So resultant of these two fields is given by like this. So this is the resultant electric field E at P. This is the resultant electric field. So To find the resultant electric field at P, we have to resolve two fields E plus Q and E minus Q into rectangular components each. First, we have to resolve this E plus Q into rectangular components. We have this E plus Q. Look at here. This is the field, that is E plus Q. And this field has to resolve into rectangular components. We know that rectangular components, how it splits. Rectangular components are the components which are perpendicular to each other. So this resultant electric field E plus Q is resolved in this way, like this. So one vertical component and another one is the horizontal component. So this is splits into two components. One here, it is E plus Q sin theta, and along horizontal it is E plus Q cos theta. Right? So this field is resolved into two components. One is E plus Q sin theta, and along horizontal is E plus Q cos theta. There is one more component, E minus Q. This also get resolved into the rectangular components like this. This E plus Q, how it is resolved in the same way, E minus Q is also get resolved. E minus Q get also resolved. So this E minus Q also get resolved into the rectangular component like this. Then this also get resolved in this way, like this. This is resolved into rectangular components, that is E minus Q sin theta, and along this way it is E plus minus Q cos theta. E minus Q cos theta. Right? So this E plus Q is resolved into two components, E plus sin theta along vertical direction and E plus cos theta along horizontal direction. This E minus Q is also get resolved in vertical direction downwardly, and E minus Q cos theta along horizontal in the same direction as that of the E plus Q. So these two gets added because they are in the same directions. But these two, E plus Q sin theta and E minus Q sin theta, get cancelled. They get cancelled. Why? Because they act on the same line. But they are opposite in direction. Hence, E plus Q sin theta and E minus Q sin theta get cancelled. What remains here simply, that is E plus Q cos theta plus E minus Q cos theta. So these two get added now. Correct? So resultant electric field can be calculated by resolving two fields, E plus Q and E minus Q. So this E plus Q is resolved into rectangular components, right? And E minus Q also get resolved into the rectangular components. And finally, what we get here, it is like this. So resolution is done in this way. So it is E plus Q. So it is resolved in this direction. It is E plus Q sin theta, right? And there is one more, it is E minus Q, it is E plus Q cos theta, and here it gets E minus Q sin theta, and this also get here. So here we have the two resultant plus E minus Q cos theta. So the resultant of these two, E is equal to E plus Q cos theta plus E minus Q cos theta. right? Because E plus Q sin theta and E minus Q sin theta get cancelled. What remains here? Only the E plus Q cos theta plus of E minus Q cos theta. Because this also get dissolved like this, right? So E component to E split agtada, E split agtada, right? E field ಈ ಕಡೆ ಕೂಡ ಸ್ಪ್ಲಿಟ್ ಆಗ್ತದ, ಈ ಕಡೆ ಕೂಡ ಸ್ಪ್ಲಿಟ್ ಆಗ್ತದ. ಈ ಫೀಲ್ಡ್ ಈ ಕಡೆ ಸ್ಪ್ಲಿಟ್ ಆಗ್ತದ, ಈ ಕಡೆ ಸ್ಪ್ಲಿಟ್ ಆಗ್ತದ. ಎರಡು ಡೈರೆಕ್ಷನ್ ದಲ್ಲಿ ಇರತಕ್ಕಂತ ಫೀಲ್ಡ್ಸ್ ನಾವು ಆಡ್ ಮಾಡ್ತೀವಿ. ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ದಲ್ಲಿ ಇರತಕ್ಕಂತ ಫೀಲ್ಡ್ಸ್ ಅನ್ನ ನಾವು ಏನು ಮಾಡ್ತೀವಿ? ಕ್ಯಾನ್ಸಲ್ ಮಾಡ್ಬಿಡ್ತೀವಿ. ಯಾಕಂದ್ರೆ ಅವು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ದಾಗ ಸೇಮ್ ಇದಾವೆ, ಬಟ್ ಡೈರೆಕ್ಷನ್ ದಲ್ಲಿ ಇದಾವೆ ಅಪೋಸಿಟ್, ರೈಟ್? ಸೊ ಇಷ್ಟೆಲ್ಲ ಡಯಾಗ್ರಾಮ್ ನಾವು ತಿಳ್ಕೊಂಡಪ್ಪ ಅಂದ್ರೆ ನಮಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಟ್ ಪಾಯಿಂಟ್ ಪಿ ಕಂಡುಹಿಡಿಯಕ್ಕೆ ಈಸಿ ಆಗಿರ್ತದೆ, ರೈಟ್? ಗೊತ್ತಾ? ನಾನು ಮತ್ತೊಮ್ಮೆ ನಿಮಗೆ ಇಲ್ಲಿ ಏನಪ್ಪ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ತೋರಿಸ್ತೀನಿ ಟು ಫೈಂಡ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ರೈಟ್? So we will derive the expression here now. So say here there is one electric dipole. There is an electric dipole plus Q and minus Q. Let O be the center of the dipole of distance A. Okay, say that let P be a point at a distance r from the center of the dipole. This is the point P. At point P we are going to find the electric field that is at a distance r from the center of the dipole. We will name it as A and B. Okay, so the electric field due to the positive charge is away from the charge, so it is E plus Q. It is away from the. Then electric field due to the negative charge is towards the charge, so it is here E minus Q. E minus Q. So the total resultant electric field is E. That is E is equal to E plus Q cos theta plus E minus Q cos theta, right? Okay, so we are going to find the electric field at this point. So from figure we can write AP square is equal to AP square is nothing but R square plus of A square. R square plus of A square, right? So if it makes this angle theta, this is also theta, this is also theta, because they are alternate angles. This is also theta. These are the alternate angles. This is the alternate angles. Therefore, we can write AP is nothing but R square plus A square bracket raised to 1 by T2. Therefore, cos theta, from this figure we can calculate cos theta is nothing but what? A divided by R. A divided by AP. A divided by AP. So this is A divided by AP is nothing but what? R square plus A square raised to 1 by 2. Alright. So this is the direction of the dipole moment. This is the direction of the dipole moment. Look at the direction of the dipole moment. We know that direction of the dipole moment is from negative to the positive charge. Here the resultant electric field and the direction of the dipole moment is opposite to the each other. Alright. So the electric field at P due to the positive charge. The electric field at P due to plus q is E is equal to E plus Q, I will write E plus Q is equal to electric field at this point due to the positive charge it at a distance of what? AP square, right? Because we know that E is equal to 1 by 4 pi epsilon naught Q divided by R square. At a distance R we have the R square. What is here the distance? That is AP square. So we write it is 1 divided by 4 pi epsilon naught Q divided by, what is the distance here? That is AP square. This is what the distance. AP square is equal to what? That is R square plus A square. Similarly, electric field, we will write this P cap. The electric field at P due to minus Q is, that is also same, is equal to E plus Q is equal to 1 divided by 4 pi epsilon naught. What is the distance? This is PB. PB is nothing but the AP. This is also same, that is Q divided by R square plus A square. Okay, that is P cap. Right? So now, hence E plus Q is equal to E minus Q. Hence E plus Q is equal to E minus Q. Now resolve two fields. Resolving two fields. E plus Q and E minus Q into rectangular components each. Then the components E plus Q sin theta and E minus Q sin theta acts on the same line, but opposite in direction. Hence they cancel each other. And the components E plus Q cos theta and E minus Q cos theta acts along the axis of the dipole. Therefore, they gets added. Then the resultant electric field at P is given by, this is the resultant electric field, E is equal to, I will write minus E plus Q cos theta plus E minus Q cos theta P cap. Alright, Why I write here a negative sign? Because the direction of the dipole moment is opposite to the resultant electric field. The direction of the dipole moment is opposite to the electric field. That is why I have written here minus. So this is the resultant electric field. We know that is E plus cos theta plus of E minus cos theta. Or we will write this like this. That is E plus Q plus E minus Q cos theta P cap. Okay? Substitute the value of E plus Q and E minus Q. What is E plus Q? It is 1 divided by 4 pi epsilon naught Q divided by R square plus A square plus of 1 divided by 4 pi epsilon naught Q divided by R square plus A square. Alright? R square plus A square. Cos theta. What is cos theta here? Cos theta is nothing but A divided by R square plus A square raised to 1 by 2 P cap. Okay? Therefore, minus of plus Q and plus Q. Plus Q and plus Q is equal to the 2Q. So it is 2Q divided by 4 pi epsilon naught R square plus A square into A divided by R square plus A square raised to 1 by 2. It is P cap. Now look at here. There is one R square plus A square into R square plus A square. It is in the form of what? A raised to m into A raised to n. Right? A raised to m into A raised to n. This is nothing but what? A raised to m plus n. What we have here? It is R square plus A square into R square plus A square raised to 1 by 2. It is nothing but what? R square plus A square raised to 1 plus 1 by 2 is nothing but what? 3 by. So it is 3 by R square plus A square raised to 1 into R square plus A square raised to 1 by 2. This is the A raised to m into A raised to n. You get what? M plus n. So 1 plus 1 by 2 is nothing but the 3 by 2. So I will write directly minus 1 by 4 pi epsilon naught Q into 2A divided by R square plus A square raised to 3 by 2 P cap. Right? So I will write it as the R square plus A square raised to 3 by 2. So we get what? E is equal to, but dipole moment P is nothing but what? Q into 2A. Q into 2A. Therefore, I write here that is E is equal to 1 divided by 4 pi epsilon naught Q into 2A is nothing but what? P. It is R square plus A square raised to 3 by 2 P cap. It is minus. Minus of 1 by 4 pi epsilon naught P divided by R square plus A square raised to 3 by 2 P cap. For short dipole, say that R is much greater than A, we neglect A square. We can neglect A square. We can neglect A square. Therefore, we write that is E is equal to minus of 1 by 4 pi epsilon naught P divided by R cube P cap. Right? So this is the expression for the electric field at a point on the equatorial line. E is equal to minus of 1 by 4 pi epsilon naught P divided by R cube. Right? So if we neglect A square, What remains here? 0. So r square raised to 3 by 2 is like what? 2 to get cancelled, remains what? R cube. So this is what the electric field at a point on the equatorial line, that is minus 1 by 4 pi epsilon naught p divided by r cube. Right? So this is the expression asked in the examination for you marks. Right? So many times this expression is asked in the examination. This is very, very, very important. Alright? So first of all we have to understand the figure, then we have to derive the expressions. Right? Okay. So this is what in the today's class. In the next class we will discuss about the continuous charge distributions and Gauss law. Okay.